Why don't some planets have magnetic fields? This is Venus, a world of crushing pressures and scorching heat. But what if I told you that billions of years ago, it might have been a completely different place? It might have had oceans, and it might have been, well, a lot more like Earth. So what went so wrong? The answer seems to lie in a hidden shield it was missing, a shield that protects us every single day. Our home, Earth, is wrapped in an invisible force field, a magnetic shield that stretches far out into space. Think of it as our planet's silent guardian, protecting us from a constant barrage from the sun, the solar wind, a stream of charged particles blasting away at 1,000,000 miles per hour. Without this shield, the solar wind would strip away our atmosphere, boil off our oceans, and turn our vibrant, living world into a barren rock, a lot like Mars. So, how is this planetary shield actually made? And why do some worlds, like our own neighbors, not have one? To figure that out, we have to look deep inside and find the 3 key ingredients for a planetary magnetic field. Generating a magnetic field requires something called a dynamo. You can think of it like a planet-sized electrical generator, and it needs a very specific recipe to work. First, you need a big volume of liquid that can conduct electricity. Here on Earth, that's our outer core, a massive, churning ocean of molten iron and nickel. It's like a beating heart of liquid metal at the center of our world. Second, you need energy to get that liquid moving. Just like a pot of boiling water on the stove, heat, escaping from the planet's deep interior, makes the molten metal churn in powerful, swirling currents. This process, called convection, is the engine that drives the whole thing. And third, you need spin. As a planet rotates on its axis, it wrangles all that churning liquid into organized, spiraling columns. It's this organized flow that lets the electrical currents build up and create a strong, stable magnetic field. A liquid conductive core, convection, and rotation. Those are the 3 key ingredients. When a planet has all 3, it gets a powerful shield. But what happens when one is missing? Let's take our first trip to Mars. Today, Mars is a frigid desert world with an atmosphere less than 1% as thick as Earth's. But it wasn't always like this. Billions of years ago, Mars had a thicker atmosphere, flowing rivers, and maybe even oceans. And yes, it had a magnetic field. So, what happened? The problem started deep in its core. Because Mars is much smaller than Earth, it lost its internal heat a lot faster. As its core cooled down, that churning motion in the liquid metal slowed, and then it just stopped. The dynamo died. Some research also suggests the core's specific chemistry, with different liquids separating, is what ultimately killed the convection currents. Without its magnetic shield, the solar wind was free to hammer the planet, relentlessly stripping away its atmosphere over millions of years until it became the barren, red rock we see today. Now, what about our other neighbor, Venus? Venus is almost Earth's twin in size and likely has a similar molten iron core. So, ingredient number 1? Check. And with its incredibly hot surface and active volcanoes, it almost certainly has enough internal heat to drive some convection. So, ingredient number 2? Probably a check. So, why doesn't it have a significant magnetic field? The culprit is the final ingredient: rotation. Venus spins incredibly slowly. A single day on Venus lasts longer than its entire year. That sluggish rotation just isn't fast enough to organize the churning liquid in its core and build a dynamo. The engine might be running, but the mechanism to align everything and generate the field just isn't working properly. So there you have it. A liquid metal core churning with heat and organized by a planet's spin. Earth just happens to be in a cosmic sweet spot, with all 3 ingredients working together to create the shield that protects us. The stories of Mars and Venus are cautionary tales, written right here in our own solar system. They show us that a planet's ability to hold on to an atmosphere, to keep its water, and maybe even its potential for life, can all hinge on this invisible force. The difference between a thriving, living world and a desolate rock can come down to a magnetic field. It's a fragile gift, and it's the silent protector that makes our planet the vibrant blue oasis we call home. If you enjoyed this trip through our solar system's biggest mysteries, be sure to subscribe and turn on notifications for more journeys into the science of our universe.